life, which much less than 1 in 10 people see. It's a thing that cannot be explained. Hasn't been traditionally been explained. And you get, like the Nobel laureate Pietro Capizza, who won the Nobel Prize, I think in the 70s, for in the 30s or something, doing superfluids in liquid helium, right? He tried to describe in the 1950s how ball lightning forms. So you have a Nobel laureate that's willing to discuss these things. So like this is not a fantasy.
Right.
And then what you're doing is, how are you organizing matter so that you can get it into a small location where it can all interact, and it does it in a gentle, natural, not fighting the desire for them not to be together. Mm-hmm. Well, you must have a thing that is able to bring things together. And you can say, like, maybe you've experienced recently in this environment here, you know, tornadoes. There's been these terrible tornadoes, but when you're seeing everything broken up, what you're not seeing is it's all coming up to a point, mm-hmm. right? It's the chaos you're seeing, but you're not seeing the order that's being created out of the chaos. And so that's what these structures do. They have a focal point, and they have a focal point fractally in them, and they are able to interact with ordinary matter and dark matter. And dark matter, it doesn't, like, so if you look at the, dark matter has energy because E equals mc squared. So if it's matter, you've got a lot of energy in that matter, even though you can't detect it. Now what is dark matter? Dark matter is typically something that you cannot detect using electromagnetism. But it's still matter, and it still exists. Mm-hmm. So if you take all of the luminous matter that we can see, you know, all of the stars, all of the planets, everything, like all of those kind of nebulae, that is 0.4% of the mass of the entire universe. Okay. If you look at the black holes and the non-luminous matter, ordinary matter, baryonic matter, that's in the universe, that's 3.6%. Add those two together, you've got 4%, right? Now there's dark matter, and that's up to 22%. 22% over 4, that's 5.5 times more dark matter in the universe, which is everywhere, than there is everything you can see, including the black holes and plasmas that you can't see, right? So there's a lot more of that than there is of everything we're made from, okay? Mm-hmm. If you can access that dark matter, then you have something that is so much more powerful than stars, than black holes. Mm-hmm. It's 5.5 times more energy that you can capture. How do you capture it? You use a thing that is called the toroidal moment, and it is an electrodynamic tool which gives you access to the dark matter. And it is based from ordinary matter by creating a complex current structure, but it's actually quite simple. You need at least 2 tors, and in each tor you need at least 2 tors, and in each of those tors you need 2 tors. You need a wheel within a wheel within a wheel. Mm-hmm. And that allows you to create toroidal moment, and that allows you to cohere this dark matter into this point, and it's the dark matter itself that is able to transmute elements. And so when you want to create oxygen out of carbon and hydrogen, mm-hmm. you need to take the carbon, which is 12 nucleons, and you need to keep pumping hydrogen into it, and at least 2 of those hydrogens need to become neutrons, so you go from carbon 12 to oxygen 16. So you add 2 protons, 2 neutrons. The neutrons are formed by adding 2 electrons that are already in the system, and you do that by using dark matter in the form of a relic neutrino. So you convert CH4, methane, which is what Malcolm Bendall had in his 400 kVA generator in Australia, which is the only one we can actually say is doing this process for certain, although the one that had the so-called plasmid coming out and in Thailand maybe 7 or 8 years ago, that should have done it. And that was the one that got me interested in whether it's doing the job or not. Mm-hmm. And so if you take carbon, hydrogen, and hydrogen, and hydrogen, and hydrogen, i.e. methane, and you convert 2 hydrogens into neutrons by taking the 2 of the electrons, and you fuse that whole thing into oxygen, you end up with oxygen, and basically you are producing oxygen from methane molecule, essentially. That's one thing. But if you take carbon and oxygen, you fuse them, you get silicon, which is the second most abundant element on Earth. Oxygen is the most abundant, right? So if there was a process that accounted for the abundance of elements on the Earth, you wouldn't be surprised if you didn't have oxygen and silicon coming out. And then silicon dioxide, that's basically most of rock. Most of planet Earth is silicon dioxide. If you keep fusing this, you get a thing called iron, which is the core. And it's also a large portion of the body of the crust of the Earth as well. And what you see in the centre of Malcolm Bendall structures is these iron-rich crenellated spheres surrounded by carbon and oxygen and calcium, which is made of alpha particles as well. And calcium is again one of the most abundant elements in the Earth's crust. The other one that's the most abundant is aluminium, which is when you take carbon and oxygen, you fuse them, and you get aluminium and a hydrogen atom. Okay, so the answer to the process is the Earth's crust, 4.5 billion years worth of it, with lightning bolts, with water and the hydrodynamics producing these clusters, water coming up through mid-Atlantic hydrothermal vents and coming through cracks. And when you get your mineral water, is the mineral dissolved out of the ground? Or is it synthesized by the cavitation, the temperature and the thermodynamics going on in the process of the water coming up from under the Earth to the outside of the Earth? Maybe it's a bit of both. Maybe the elements that it is dissolving were already synthesized by this process earlier on in the Earth's geological history. So when you look at the elements there, I would predict I would see titanium. Why? Because, and I'll read this, I know I asked you to read it, but like far in the universe, nuclear collapses very often take place where the gravitational force after stars consume their fuel. Since the electromagnetic force is about 40 orders, not times, but orders, stronger than the gravitational force, it should be easy to induce similar nuclear collapses by electromagnetic force in laboratory. But we never knew until now how to do that, now being 2000. Recently, the author discovered a nuclear collapse which was induced by electromagnetic force in the laboratory. During studying the mechanisms of so-called cold fusion, several kinds of nuclear reaction were directly induced in by the electromagnetic force called electronuclear reactions, which were so found to occur in special state of hydrogen clusters that this author referred to as itonic clusters. I can explain that, but it's not necessary. Or micro-ball lightning. The nuclear collapse was one of the most remarkable reactions among electronuclear reactions, called electronuclear collapse. Furthermore, very amazingly, completely broken materials by ENC were found to be regenerated again into thin tubes and films of conventional elements such as carbon, oxygen, and iron. The latter process was called electronuclear regeneration. Now, in fact, what you also say is titanium. And what is titanium? Titanium is the fusion of COO, carbon dioxide. Titanium metal, which is one of also the most abundant elements in the Earth's crust. So we have a mechanism by which, if you can create ball lightning, you can do transmutation of elements and actually release energy. But sometimes you you absorb energy in these processes as well. But what we're trying to do is potentially sequester the carbon dioxide, so we get around with the problem of global warming, blah 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 blah, whatever it is this week, and global boiling. I think we're on to now. Yeah, it wasn't scary enough when it was climate change. It's now global boiling. We're going to change all of the images of the temperatures to red and like glowing red, and when it's actually cooler than it was in 1976 when they just had the temperatures all the same with on the graphics. So here's the thing. How do you generate these structures that do electronuclear collapse in ball lightning in the thunderstorm generator? Very simply, you increase the water content going in. That's the bubble. A thing that doesn't ionize but potentially can energize the air going in might assist. I don't think that's necessary. The water has proven to do this in the past, since the 1930s. Now the water could form a bubble of water gas where you either have the negative facing out or the positive facing out, and in which case, if you have a positive sphere and a positive sphere, or a negative sphere and a negative sphere, they're going to repel each other. So they're like buckyball clusters. This was predicted by MIT, but when I visited Roy Schnamazli, he had a $1 million system where he took the HHO gas that he was producing, he called it a Mars gas, he put it in there, and he found clusters of buckyball-shaped water molecules, where the water molecules are literally in a ball and they can actually contain gases inside. So it's actually a little bit of interesting magic. That isn't going on in Malcolm's system, but I think Malcolm came on somehow to that might be going on in the bubbler. Whether it is or it isn't, in my view, is irrelevant. What is most important is you're maximizing humidity. Why? If you are in a hot, dry environment, your engine runs like shit. Yeah? You get lots of black smoke out, whatever. If you're running at high altitude in a dry environment, your engine almost doesn't work, right? The reason being is you've got a lack of oxygen. What you need is a cold, moist environment. The coldness increases the density of oxygen in there, so you get a better burn of the hydrocarbon. And if you add water in, that will add extra pressure, which increases the thermodynamics in there, but it also cools the engine, so it maximizes certain parts of the pressure. This is all known physics. Mm-hmm. Now, the second thing is, what he's got a heat exchanger. You've got the thermal energy coming out of the engine, and it's coming down, and there's an exchange between that and the highly moist air coming in, right? What that does is it increases steam. And that forces a back pressure on the bubbler, which maximizes the pressure in the air going in, and the water vapor is now all steam, right? But it can't go back out because you've got a water hammer effect on the bubbler. So that maximizes the pressure. It's like a supercharger going in. Now, if your steel in there has nickel in it, and or it is over 600 to 650 degrees C, you get a thing called thermocatalytic splitting of water. And so the water then converts into hydrogen and oxygen. It does that heterogeneously. So sometimes you have OH minus, you have H plus or H star, which is atomic hydrogen or proton individually, or it's all oxygen radicals and hydrogen radicals, or H2 gets formed and so on. So you've got this whole smorgasbord of the fractioning of hydrogen and oxygen from the water coming in alongside with the injected fuel in the carburetor, and that's coming into the engine. And so you've increased the pressure, you've increased the amount of available oxygen in there because you've thermocatalytically split the water, and it goes into the engine. You then trigger the explosion. What's coming out of that is highly charge separated material. You've got charge separated material going in, so even in the vortex going into the system, you can have some plasmoids, as he refers to them as, but exotic vacuum objects, these fractal toroidal structures, forming before they even go into the engine. Okay? Then you blow them up. Now, there's a guy called Anatoly Klimov, and he saw something in a presentation in 2019, and he realized that the cat was out of the bag, so he presented in 2020 work that was done in Soviet energetics. They had a microwave plasma producing charged structures inside a chamber, and then they used a spark discharge to blow up these structures, and then they went through a polycarbonate capillary which produced a shear of these substructures. They reformed into toroidal fractal structure, and it comes out and it produces these vortex beams that come out. This is what you can imagine is occurring after the explosion in the actual internal combustion engine. The exhaust is coming out and it's going into a vortex area. Now, what I was showing you earlier, when you have ball lightning, this is a guy called Dijkhuis, and it's his theory. It's presented in the New York Journal in 2000 or 2001. If you take a rubber band and you squeeze it, like so, you've got a current loop in a plasma, right? Not your tokamak, not your thing that's never going to work, but a naturally organized plasma. And then you push it, so you ram it against something, and you're shearing it this way because it's spinning around that way, and because it has to go down this way, you're shearing it not only that way, you're shearing it that way. You've got multi-axis shear. You're getting that rubber band, you're twisting those plasma loops, they are forming a kink in stability, they then rejoin into a little torus. And then that torus is rubbed again, and he describes in his calculations that this process incredibly produces smaller and smaller and smaller tori, and they have their magnetic vector, and they join together through their magnetic vectors to produce a toroidal moment. And the toroidal moment can join together into a toroidal moment, that toroidal moment can join into a toroidal moment, that toroidal moment, and so on. So you get a fractal toroidal moment. That is your ball lightning. And the ball lightning can be either left or right chirality. One left is yin, that creates matter. The yang chirality deconstructs matter. One is the south pole and one is the north pole. One is the sun, one is the moon. And that is what's causing that plasma loop, because you get a north and a south inside the reactor. They can't go through because of the electrodynamics and the charge status, but what can go through is the neutral wormhole that you see coming out and inside the reactor. And that's what's going on there. So when I saw that, I had to get involved, because we produce that in our devices, and it had also been seen in the Global Environmental Energy Technology GIT and in independent replications thereof, and shown on YouTube for many, many years. So it was doing the same process, it was making the same claims that the GIT could do, but it was clearly an easy device to make relative to the GIT. People have replicated the GIT, but it was very, very difficult to do, right? So it's clearly doing the same thing. So the only thing that I know has been fully verified, in my view, to create the effect but not necessarily create all the claims, I can just say what I know we can know, is Malcolm sent me these pictures of this 24-inch sphere that was taken off this 500-hour run, 400 kVA methane device that he had down in Melbourne, running over 500 hours over a period of about 8 years. Okay, and he started sending me these videos inside, and he was seeing these sparkly bits, and I was thinking, well, the sparkly bits could be silicon dioxide, they could be calcium or whatever. But I just immediately wrote back and I said, stop messing around with it, put it in a bag, and I'll be over on the next flight, right? I said, because you're contaminating it. So I came over with macrophotography, microscopy, and so on, and I said, I would expect to see, if it's doing what I think it's doing because of this flight. I didn't even know this thing existed when he started sending me those images. If it's going to be doing that, it's going to be doing what, it's going to have inside of it what I see in Matsumoto's system, which are these hexagonal blobs with a ring spot.
Yeah.
Okay? Here. These structures here. These structures here. It will be an array of these things on the inside of the surfaces of the out part when it's coming out of the engine. That's what I expect to see. I turned up, turned on the camera, walked over, there they go, right? And so I gave Johanna James, stage name, a quick, you know, how to use the macro photography. She took some great footage, full credit to her. I used the microscope. And I said, well, Malcolm, now you need to give me a section of this. And he said, oh, I want to be in the Smithsonian, you know, it cost me $50,000 or someone anyway. And so like, I said, well, that's all I can do for you then. Because I had already predicted that if his system was working, before that I even knew that this thing existed, that if it was doing the effect that this sort of glowing arc was suggesting, then it would have iron-rich crenellated spheres. Now I had seen the things that form around the core where you see the iron-rich crenellated sphere when the pseudo-magnetic monopole collapses, not north or south, right? It's actually on the south. But anyway, so the way that collapses. And so a couple of days later, he sent over Kian on the reverse one-day flight there and back, and he gave me a sample. A couple of days later, I went up to Prague, put it under the SEM, and within a few seconds, we see the iron-rich crenellated spheres, which we had observed in many systems that do this nuclear transmutation process. Now, there is a guy called Sviatomenko, and he learnt the 1950s Soviet method of cold nuclear transmutation. And he wanted to really do exploration into this, and so by 1999 he'd got a sponsor and access to the old Soviet isotopic factory outside of Kiev, and he set up a thing called Proton 21 Labs, and he had a 300 joule electrical discharge through hydrogen through a dielectric barrier. And this produces turbulence, relativistic discharge, a little bit of energy, but it's a very small pulse, into a sample of metal. Any metal in the periodic table, you get all of the elements synthesized out of the periodic table. And in his patent in 2003, he has a iron-rich crenellated half sphere, which is hollow inside. By the way, all these spheres are hollow, and it's embedded in the pure copper substrate, which it went into. And in a 2005 article in a Kiev newspaper, he said that it's dark matter that causes this reaction to occur in here. In 2014, that whole laboratory, about the size of this ground floor, was shipped to Illinois, Chicago, Illinois. They verified the process, 10,000 experiments in a row, all produced transmutation of elements. From the first to the 10,000th. They verified it in Illinois. They had a company called Proton Scientific, and it was sent to the to Brookhaven National Laboratory and became part of the US fusion program, and the website was taken down. So now you can't follow what Proton Scientific is doing. It's now behind the black doors, right? But what he sees, the iron-rich crenellated sphere, there was no iron in that system. You had like a copper pin and a pure copper, 5 nines copper pin, 5 nines copper plate, hydrogen. And there's an iron crenellated sphere, which is hollow, and he says it's dark matter that's in the centre. For it to be dark matter in the centre, which also Ken Shoulders says it's dark matter, and this guy says, Takaaki Matsumoto, he says it's dark matter is involved, or at least neutrinos are involved, and everyone agrees that this is the case, except for the people that find it inconvenient to discuss it. You have a situation where you can actually synthesize matter, transmute matter, and desynthesize matter. But whatever, you have a mechanism by which you can capture basically unlimited amounts of energy in a very low energy catalytic initial way to create these structures, and then that they can transmute the material that is available in the environment to the things that they want to be more of. And carbon is uncommon, right? Oxygen is the most common, silicon is the next most common, and he says what you get out of these systems is titanium, which is CO2. So, and we've replicated those observations, actually before we even knew that he'd done it, and since, by the way. So I saw titanium in the inside of the outside of his reactor. I saw iron-rich crenellated spheres, tens of thousands of them. Now, in a cavitation experiment, where we've got standing waves and so on, which is an experiment that a 3-year-old can learn to do and conduct in 7 minutes and uses about $40 of equipment, we also get iron-rich crenellated spheres, which I also predicted. So I predicted that he would have iron-rich crenellated spheres in the Malcolm Bendel device when I gave a presentation in Zurich, right? Before I'd ever touched any of his equipment. And it turns out to be the case. And so that is essentially it. And I can walk you through how the toroidal moment, with science, starting from Winston Bostick's work, who gave the name plasmoid to these structures. He didn't know that the very first experiment he did was making a toroidal moment. He didn't know that, or at least he's never discussed it. And then you can see the progression through the understanding and how this is definitely what's happening in the system. Now, in the experiment we did in California, where we produced these iron-rich crenellated spheres in water, that's like really cold, no boiling going on there, just by the electrodynamics involved, because the water polar molecules are going around, they're producing the toroidal moment. Anyway, it does the same thing. We produce a lot of these iron-rich crenellated spheres. The thing is, it only ran for 900 seconds. So my reservation in this whole thing is it a particular resonant environment where you get particular standing waves, everything's at the right temperature, and the whole thing gets covered with thousands and thousands of these iron-rich crenellated spheres, and that's when it works. And does it work all the time? That is not proven to me. I can only say what I know. It was producing ball lightning in that particular device, and there was at least one other device, the one that I was sent the video of from Thailand 7 or 8 years ago. It's happened at least twice where the right conditions have been available, and we know it's quite easy to produce in a range of different ways. His technology, potentially, if it produces it most of the time, has the potential to transmute matter on a continuous basis. Water cavitation can produce cavitation which produces transmutation on a continuous basis. Kladoff, 1983, 2 heat generating patents. By the 1990s, he showed that the longer you ran it with the same water circulating, you started off with 5 elements, then you had 75, then you had hundreds of isotopes being produced, right? Just by running water through cavitation. The cavitation produces these electrodynamic structures, the electrodynamic structures produce the fractal toroidal moment, that produces all the element synthesis in there. So we know you can produce a continuous process. My remaining question is the thunderstorm generator able to produce a continuous process? Does it only work for the first time you turn it on whilst it's warming up? Can we run the test for 10 days and it's continuously doing that? I don't know, because I haven't had access to a device. When we did an isotopic analysis in California, it was doing interesting things with the output of the gas. But we didn't have the muffler on it. Was the muffler affecting it? Because we took the muffler off, you know. So there's definitely something there. Is it there all the time? I don't know. It does use ball lightning. Ball lightning, I will show you, and I can give you the images and the papers and the patterns and so forth that explain the science when you put it all together. And yeah, if he's done it, well done. You've whatever, all the wrong questions, flawed character, whatever. It doesn't matter. All of that's bullshit.
Sure.
Right? It's at the end of the day, Malcolm has one of these incredible traits, which also Rossi does. Regardless of whatever happens to him, he still manages to get people into the same room and push the story forward. And that is a real skill. It's an incredible skill, especially when people don't want to be there. Right? So, you know, so he's making things happen. And yeah, do you have any questions?
Yes. I'm gonna have to formulate this in my mind. And really what I think we should be planning for is, an hour I'm not gonna be able to get into this level of detail. However, give me a few months, Joe Rogan. Mm-hmm. That's what I want to get briefed on and be ready for.
Right.
We'll
pause here,
mm-hmm.
then come back in another half an hour, and I'll start showing you the images.
Okay, good.
And then we'll do another 40 minutes, and then we'll pause, and then do another section, and you can have some time to think. Because I don't know about you, but when I've had some information, I can think about it in my subconsciousness, mm-hmm. and it starts to dawn on me after a period of time.
Same process. In fact, I'm even thinking maybe I ought to take a little nap.
There we go. I'd say I'd join you, but that would be very wrong.
It could raise some questions.
It could raise some questions. Yeah, like does he like fuzzy beards?
Well, I would imagine at this conference that we're going to, what Randall's going to. They'll also ask some really, really basic questions about the thunderstorm. They'll probably ask, well, where can you use it? You know, which is basically the answer is on all sort of fossil fuel, oil, gas.
It needs a hell of a lot of effort to make it work. Potentially, if it is based on resonance, and Malcolm makes a huge point about it being based on resonance, if you add a little centimetre at the end, it's going to change the whole thing. And if this is not exactly the right, I think it's much more tolerant than he likes to make out, and it needs to be much more tolerant because if you're taking the revs up and down on an engine, it needs to be able to handle all that variation. Yeah, otherwise, it's only going to work on fixed generators in
is it going to work
hybridized powertrains.
That's what we want to know.
Yeah, like a generator is the right thing because it tends to run at fixed frequency, producing the energy and so on. A hybrid car where you've got an electric motor, battery, accumulator, and then you've got an engine that's just constantly generating that, and you're using peak demand. There's not so much change in those kind of systems. It's going to be easier to implement, but sooner or later we'll solve the problem.
The answer would have to be, well, it's still a little bit more in a process of R&D there. To be honest.
But I think it's going to be simpler if it is working. I think it's going to be simpler than people think, and like when you put it out into the world will solve the problem very quickly.
Mm-hmm. There's a lot of things that run at for instance, we're going to get it into Dubai, into a cement factory, and there's a lot of...
they're continuous processes.
Yeah. So that's at the moment, that's really ideal for I'm just thinking of the questions that are going to be thrown at you that are going to be... They've just heard about the
specifically on cement, and in fact I met in London the major manufacturers of cement in Europe. They brought up the UK people, and they were from France, and they were looking at this because they actually have a legal requirement to reduce their carbon output by 2030 or 32. So they actually have it, and they don't really have a solution right now. So they're looking at this as a real practical solution. Mm-hmm. And cement production produces some of the largest amounts of CO2 outputs of any process that there is, especially when you're putting down those pads to put up the wind turbines, right? A lot of cement is used to make wind turbines. Mm-hmm. And so they need a solution, and as you say, it's a continuous process. A huge market. So, fix the problems you can fix first. Use that money to solve the problems of putting it on other devices. Mm-hmm. So, is it a perpetuum mobile? No. Is it magic? No, it's based on actual science. Has it been proven before? Absolutely, certainly, yes. Is it based on things that there is the mathematics that we can go and study? Yes, here are the mathematics, here's the equations, here's the process. What are the risks? There is a risk of a type of radiation that comes out of these structures, but it's reasonably well understood by our project and by people in Russia, and unfortunately, if people don't want to talk to Russia because they go, oh, Russia bad, you know, we can solve that problem. But, you know, if you're worried about the radiation this puts out, you need to stop everyone welding, and you need to stop anyone that's anywhere near a fast rotating metal object, because that puts out the same radiation, okay? Now, this radiation form can actually create good health, but it's just not good in certain fluxes and in certain situations. But we have an idea of how to shield for this. So we're already working up front on solving the problem, which already exists in various industries, which people are unaware of. So if you go to look at studies, there are people that have higher cancer rates that work as electrical technicians. And people don't really understand that. People say, oh, you get high cancer rate because you're using welding, because people don't wear the right protection, they get UV exposure, but it's not that. It's not just that. That is a thing, but it's not just that. So we will solve problems that weren't even known about by solving the problem, enabling us to use this technology. And the other thing is, this is just the start of this journey. What this technology enables is everything that the people in that room would really think were amazing. That's the point. This is the start of all of the important science discoveries that we're going to discover moving forward.
Yep, including propulsion.
Yep.
Propulsion, yeah. That's, you know, I want to make a wood-framed, steam, coal-powered UFO that goes faster than light. Because I want to do that scene that we just saw Hulk Hogan do. I want to show how absurd it is that we've been living this lie when this technology is possible to make out of basic stuff that anyone could have had 5,000 years ago.
Yep. Here, here.
What did this gentleman say? Clay?
Chalk, charcoal, and clay.
Chalk, charcoal, and clay.
Right. Yeah.
That was brilliant.
That's the alchemy.
Yeah, well, it make Freemasonry, so that's
Right.
where it's from. Yeah.
Because charcoal has the potassium in it. That's actually how you get potassium initially. It's isolated from electrolyzing the leaching product of burnt wood. It also has carbon in it, and it also has, you know, you have clay, that's silicon, and it will have other elements in silicon dioxide.
Other things.
Yeah, and chalk is calcium carbonate. Yeah. So that's that one. So go and have a snooze.
Well,
I'm going to have a swim.
Thank you, well done. Good basic questions, because at the end of the day,
I think
who
that's what-
understands how that works? They want the applications.
They want to know, how it's going to make
Yeah.
society better, how can it clean up pollution.
But there is, still a lot of just convincing people this is a science and
Yeah,
it can be
well-
taken seriously, that there's so many references out there. You know, I think it's important to be armed with those resources.
Oh,
To
absolutely.
just, because that is going to be the lashback if there is one,
No, but I want to give you
Yeah.
a slide where you're sitting on Joe Rogan and they say, well, how does this cohere matter? Well, there's this paper by Wisniewski in 2008, and it's cited by the Moscow Nuclear Physics Institute to explain the monopoles that they observed in plasma flow discharge, which lived for 2 days glowing as a torus moving over a piece of metal, right? Where they also observe other ball lightning phenomena going on, and this is a topological monopole, and that has a phase singularity. And there it is. That's the mass. It's compliant with the Dirac monopole that he predicted as the magnetic mirror image of the charge, positive and opposite.
It's a pity you can't be on this. Pity you can't be with Joe Rogan and with Randell on that day.
Well, I do that, but I'd have to be the quiet sidekick.
Well, you can be quiet, so
And I'd just come in with the bits.
we can train you.
I would just come in with the bits where I needed to, give the reference to a specific question which was extremely challenging. But I'm hoping I would be able to give you the keys. I gave 4 references to my presentation to the people in Strasbourg.
Okay.
And with those 4 references, you should be able to know most of this. And then you just refer to the fact that coherent matter through the same mechanism is the basis for the Lockheed Martin patent that was submitted for evaluation in 2011, published in 2013, called Systems and Methods for Creating Coherent Matter Waves, right? And they literally say in there, a paragraph, some of the implications of this technology are single bath thermal extraction. What's that? You've got a big bath of water, right? It's all exactly the same temperature. From over here, I can take energy from that bath and bring it over here. That seems impossible, but you can do it with this technology. You can do cloaking. You can make a piece of something in free space be basically not visible. You can also do an atmospheric lensing, so you can actually make a different piece of space into a different refractive index, so you can literally create the sun into a virtual lens and cause it to set fire off.
Mm-hmm.
You could literally burn things without ever going. You could do this from the other side of the planet, or you could do it from a satellite. You don't need to beam the energy, you just make a freaking great virtual lens in the sky, like I used to burn ants. I still feel bad about that.
I hope you're praying for it, Bob.
I did. Like, they used to eat my food, they used to get in my knickers, but like, I'm going around like this with this, this is amazing, I can fry these ants. And then I feel bad about
Quite
it.
tasty too.
I have eaten the queen ant. I have eaten the queen ants in Africa, yeah, really nice, nutty.
You know, there's a Taoist tincture for
Is there?
ants lift, you know, what is it, 100 times their weight?
Yeah.
So they get particular ants,
Yeah.
and they make a tincture out of it.
Right.
It's a
Did
Taoist
it work for you?
It's a strong tonic.
Right,
It's really good for physical stamina.
Right.
Yeah, it's really amazing actually.
Right, well there you go. And spit.
How do we get onto this subject?
That was a tangent and a half, wasn't it?
So the good news is we're filming it for you because that's going to be important because there's a lot of information and that you can review it and so this afternoon you're going to do a little bit more slides and references. Is that what's
Yeah, I'll
on your mind?
take him through those things and then he can go away and think, because like basically for these guys next week, you say, look, I'm Randell Carlson, you probably know me already, and I've got this, you know, I've studied all these kind of things that have physically happened. There is a guy that I know, and he's explored different areas of science which are underexplored. And there's another guy that I know, and he did what I did, but he did it in the microverse. And he potentially has an explanation for what this guy did by exploring things. So we're all explorers, and combining our experience within the scientific field, the practical scientific field, the actual scientific field, and the physical field, there is a potential here for a very disruptive technology, which will be the first part along a journey of incredible series of disruptive technologies.
Yeah.
Yeah. Let's see the next one.
Yeah, dangerous.
Excited.
Super. So let's take a break
Yeah,
and well done everybody.
yeah.
Really good.
Chill out. Roger,
That's good.
I'd like to get you and Susan and myself just get together just about shopping and creating some wonderful food for later on a nice dinner. So just see what magic we can produce, we can get to the shops, pick up what we need to do to satisfy everybody. Yeah.
Do you need me for that?